Well, welcome everybody at the end of the conference. I hope you still have some energy left to listen to our story that we are going to tell today. It will be about a proof of concept, what we as ING did together with the folks from Bitergia. And it was mainly focusing on reducing risk on the software supply chain. So you have dependencies in your projects, open source dependencies, but what is actually the health of these projects? So we'll take you to this journey that we had in this presentation, and we'll also share some lessons learned. And Georg will explain a lot more about the nitty-gritty details of their beautiful solutions that they have. So let's do a short introduction. My name is Peter Eigelsheim. I'm a chapter lead at the ING. ING is a bank based out of the Netherlands, but currently also globally operating in Asia, Americas, all over the planet. It's around 60,000 employees, colleagues that I have. And yeah, we provide financial services for our consumers. I'm an IT chapter lead in the Department of Global Engineering. So our department basically servicing all the engineers of the ING worldwide. So we provide them with pipelines, Scrum boards, all automated, and we use Azure DevOps for that. I'm a chapter lead, so I'm doing HR stuff for my team. But besides that, I'm also still doing engineering myself, as this proof of concept we did together with Bitergia. I've done Java development, Python, Golang. So yeah, I like all these programming languages. And besides that, I have hobbies, gaming, making music between somebody's calling it just noise, but I call it music, guitar and piano. And I like to run. When COVID started, I thought I have to move more because I'm sitting all day. So I started to run. Did it together with Georg. So yeah. Georg.
Thank you, Peter. Hi. Thank you for staying to the end of the conference with us. My name is Georg Link. I'm an open source strategist. I work with Bitergia in sales. And Bitergia is a company that has been doing open source community metrics now for more than 12 years. And we are happy to work with ING to look at their open source libraries and dependencies. I'm also co-founder of the CHAOS project. CHAOS stands for Community Health Analytics, open source software, where we standardize metrics and tooling to analyze the health of open source projects. And I also have hobbies. I like board games. I like hot air ballooning and reading.
Cool. Hot air ballooning. You go up in the sky with the balloon?
Yes, I have a friend who is a pilot, and he has a big balloon.
Cool.
So, why are we here today? What got us here?
Yeah. That's a good point, Georg. So, yeah, maybe you all remember, or maybe not, but it was a cold December night, and there was some breaking news on the software front about a vulnerability. Log4Shell. People were all of a sudden able to, by manipulating some payloads, to do malicious stuff for all the components that were using this dependency, Log4all. So yeah, Houston, we have a problem. And managers started calling around, say, hey, I heard this on the news. How is it impacting us? What do we need to do? How big is the problem? Yeah. So we send out a big communication to all the teams within ING. Hey, who of all of you are using this specific version of Log4j? Because it's malicious and it's vulnerable, and we need to take a look at it to fix this, because our systems that we also present to our customers are vulnerable. So developers started looking at it. Is there already fix published for this one? And luckily, in a short moment of time, there was a fix provided by it, by the open source community. But yeah, imagine if there was no one to fix it, then we as a bank would have a really big problem, because yeah, what do we do? do we stop these systems that are running the dependency, are using this dependency? That would mean, yeah, we are letting down our customers, and yeah, customers, they will still want to transfer money and see their financial status. So yeah, that was quite a big risk. And Georg, maybe you can explain a little bit more about the analysis, the data about this issue?
Yeah, ING is not alone. This is an industry-wide trend where we see an increase in malicious packages in what claims to be open source. We see that attackers have found a seemingly profitable endeavor because they keep increasing the attacks, and the impact on the businesses is increasing from today 50 billion anticipated by 2031 to be $138 billion to the costs that we're facing collectively. Now, if you're thinking this doesn't affect me or this only a few companies, Gartner anticipates by next year 45% of businesses will be facing a software supply chain attack. So with the flip of a coin, you might be affected. And what's the impact on the business? We know, looking back at SolarWinds, for example, that the average impact was 11% of annual revenue. So if we take 50% chance of being hit, 11% revenue impact, that's 5% of annual revenue. What are you willing to invest today to mitigate that ahead of time? That is the question here, and how do we do this? So let's shift gears and look at the problem so we understand what we're looking at. When we are using open source components in our software, that's a good thing. Developers love to do that. We know from different surveys that we have 80%, 95%, depending on which survey you look at, of source code, even in commercial software, is open source. The issue is that the software, sometimes there are other components that are being used that you're not aware of. And if you don't know what is in use, then you don't know what the risk is. And that is the first thing. You need to understand what is in your software. And this is where software bill of materials come in. And Peter, I believe you have looked at software bill of materials at ING as well.
Yeah, we surely did. Because actually, yeah, we wanted to know what's all in these projects that we have. We have around 80,000 repositories. Not all of them contain source code, but many of them do. And what all kind of dependencies are being dragged into our environments. And as a starting point for using the platform, we needed to know what kind of dependencies are all used. And we were introduced with the SBOM. So they said, hey, you need to create an SBOM bill of materials to see what all is in your systems, in your dependencies, what kind of dependency you have. So we did that. We looked at it together with Bitergia, and they did some kind of survey of the different tools that were there. And it turned out that these different tools not give one picture, but gave different pictures. So we were looking at, hey, why are there differences in these tools? And we did some more investigations ourselves and looked at other tools. And apparently, an SBOM is not an SBOM. So yeah, that's something that we still need to figure out. Like, hey, how can we get a consistent, uniform list of components that is in our projects, the open source dependencies.
Yeah, and we put a stat here from an investigation of 7 million open source components that were published in the last 12 months. Only about 1% actually delivered an SBOM with their release. So it's really important that the companies are doing their own SBOM creation and scanning. So let's assume we have the dependency graph, we know what's in our software, we've solved that problem. The next issue is trust. How do we know that we can trust all of the components that are in our software? When each application has 180 components on average, you cannot do this one by one. You cannot manually do this. So we need to scan automatically. And there are three things that we need to look for. One is licenses. Everyone understands licenses being the core foundation of open source, and we need to comply with those. Vulnerabilities, also beginning to be widely understood. The last part, under-maintained open source projects, there's little knowledge about how to do this right now. And when we look at all of open source, and we understand that there's a small 10% that really is relevant, we need to have tools in place that help us identify what those are. And for licenses, we have license scanners. For vulnerabilities, we have software composition analysis. We have vulnerability databases. For projects, we have the metrics on community health. You can also pay a vendor that is very happy to take your money to promise you that they will take care of it. What has been missing so far is forward-looking on what is going to be the situation of your open source dependency tomorrow or the day after. And I'll give you a picture. If you think of a car and you're driving down the road and you have a light come up, fuel is low. You drive to the gas station. The engine light comes on. You go to the mechanic. What happens when the car gets older and there are no more parts available? You go to the junkyard to get parts. You have to find a different solution the older the car is because it's no longer widely supported. And we have the same issue with software where it ages, and then you need to have ideally an early indicator of when is end of life or when is it no longer being supported. So this is where, from a project health perspective, we looked at, okay, how do we get indicators early on from the development in the community to know where the risk lies, that it becomes unmaintained. And what we did at Bitergia, we've been doing this for 12 years now. And even before that, it came out of university research looking at how is it possible that open source volunteers on the internet are creating high quality software that is competitive. And so we used 7 indicators across 3 criteria. One is, can the community handle the workload? So we're looking at the backlog management index, the review efficiency index, new issues coming in versus the ones being solved. What's the ratio? The second criteria was around the being able to address issues quickly. So how long is the lead time for issues to be closed or pull requests to be closed? And the third criteria was the talent in our communities. Do we have new talent coming in? How concentrated is the work in the project? Is there one single person that does all the work, or is it spread out? And what's the duration that people stay engaged in the project? And I want to be very clear. This is a proof of concept. We have a starting point to look at this. We're looking to improve this model over time. And this is the current proposal. So what we do is we take these 7 metrics, we normalize them, aggregate them into one score so that each library, each component gets 1 score, and then we aggregate those into the components. So for each component, you can then have 1 score. This is important because if you don't make it easy for someone to look at, they get overwhelmed in the data. We have so much data that we could be looking at. It needs to be simple. So I want to give you an example. I want to show you what this current iteration looks like in the software. And this is all built on top of open source software. The Chaos project has Grimoire Lab, which is the software to collect the community data. And what you're seeing is built into this software. So this is a dashboard. It's built with the OpenSearch. And to show you the different parts, I'll zoom in on different areas. One is we can filter what we are interested in looking at. So here, this is an example of Kubernetes and Golang dependencies. we get in the top right corner an overview of how the different components inside all the dependencies, how they ranked. So we have like a traffic like green, yellow, red, and then we have ultra red at the top, where the activity in the project has not been enough for us to determine a risk factor or risk score. So that's where we say very high. In the bottom right, bottom left, we have the different scores, the different metrics, and where they ranked. So each cell here says in that level, so let's say low, and then the top row is the backlog management index, there are 89 components that are low on the BMI metric. So we can see in this heat map where we might have problems, where it clusters typically. We can also drill down because we may want to investigate what an individual component, where the risk lies there. And so we can go to a separate page that has, for that component, a medium score of 4.29. And then we see in the metrics how that score is comprised. While it's medium overall, where's the high risk coming in? And here in this example, I just picked out one random. I'm not trying to pick on any open source component here. In this example, the lead time is very long. Having the individual metrics that tell us and being able to drill down, now we can say, okay, if this is a component we rely on, what do we do about it? Do we want to continue using it, or maybe we help them with their backlog to close some old issues and work with the community to get it in shape? So there are different things that we can do because we can go into the origin of how the score was computed. Do you want to add anything here, Peter?
No, it's very insightful, and I think these metrics, these are what regular developers they don't think about, I think, and it uncovers quite some interesting facts. And it's all data, right? It's all data that you gather with your tools, and it's I think very useful. Yep.
Oh, I was on the previous slide. I just noticed because I see the next slide and the current slide. So this is what I was talking about. We can see the individual metric values and then the risk value, and we have different thresholds because we also were looking at different units having different thresholds, what they consider risky for their dependencies.
Yeah, you can say. Do I find it a problem that there's less than 3 developers, contributors on this open source project? And I think that makes the model really flexible and really useful for us as well, because then we can determine, hey, what is our policy? What do we find acceptable? And reflect that in the model. So it will turn red based on the thresholds that you can set. So that's, I think, a powerful mechanism. Yep.
Yeah.
Yep.
So you've seen what is possible using the community metrics, that we can have a risk indicator. And in a way, we're using the idea of community smells. When in academia, there's this concept of code smells. When a software code looks kind of funky, you're not quite sure where there might be issues, but you can say, okay, this kind of smells funky. We can use community smells in the same way. So now that we have built this proof of concept, what are some takeaways so far?
Yeah, it was very valuable. The results are very valuable. That's we also found a project that was depending on something that has not been maintained for 2 years. Luckily, it was just an internal project for one of our workshops that we created. Actually, myself and another colleague, we created a Golang workshop, and we used a front-end framework that was not maintained anymore. But that was one of the projects that was in the proof of concept batch. Basically, we took a whole bunch of projects within our department and say, hey, guys, give us the data. It was all kinds of languages. We looked at Python, Java. Most of our APIs are developed in Java within the ING, but also C, C++, C Sharp. They were all included in that proof of concept. And yeah, it was very valuable. It gives you insights in risk that you're really not aware of. As I said before, yeah, if you're a developer, you say, oh, I need certain functionality. Oh, and it's already made by this open source project. Okay, let's drag it in and I can use it. That's very nice. And that's how it goes. They are not looking into, hey, how many contributors are working and what's the turnaround. We just want to have that functionality and have it work. And yeah, this tool gives really nice insights in other aspects that you don't think of. Another challenge we had, we were already talking about S-bombs, and the Bitergia platform. The input for that is actually the link to the open source projects. So we also had quite a challenge of, okay, now we have the S-bomb. It's clear what's all being used. How do we translate that to a code repository, so where the actual source code is maintained? We created a component ourselves. We didn't have a lot of time, so we said, okay, let's create our own component that does the translation from S-bomb to where the source code location is. But yeah, maybe we'll have to do some more investigation on if there's a product in the market or an open source community that helps us with that. As said, the S-bomb is not the S-bomb. We saw a lot of different results and not one unified idempotent S-bomb being created. Idempotent then in the sense that you use different tools. And we also have the challenge, as I already said, we're quite large company. We have a lot of developers, 10,000 teams working on 80,000 repositories. How does the solution scale, and how are we going to fit that in the process that we are running in the ING? So we have the pipelines. The developers use the pipelines. Yeah, you want to give them maybe directly feedback on the open source dependencies they are using, but maybe there's also another way on an aggregated level you want to see things. So these are still things that we need to figure out. We learned a lot during the proof of concept. But we really need to figure out, hey, how are we going to fit this solution that gives us valuable information? How are we going to fit it in our process, basically, in our organization? And maybe you can shine a little light on that, Georg?
Yes. Where are we going from here now that we have built the initial model? There are a couple areas that we can improve and new ideas that we are thinking through. One is the scalability, that right now we can analyze small batches of projects, but going to the scale of what you have at ING, the software will need to be re-architected so that we can support those new workflows. The license change risk is something that also comes up when an open source project changes away from an open source license, and then you can no longer use the new and updated and greatest and latest version. What are some early indicators that, hey, this project might be at risk from the community perspective? Are there indicators that can shed the light on that? That would be great to add to the risk model.
Definitely. Yep.
Also, digital sovereignty. We heard it this morning. Europe is very concerned with where software comes from, that Europe itself is sovereign for its digital infrastructure. And can we build that into the risk model as well, especially as legislation might come around the corner any time to say we need to keep software that was developed in certain parts of the world out? Could happen, or is already happening in some areas.
But that's life. Yeah.
It's life.
Yep.
And also, the XZ utils example brought it to light. There might be malicious actors. Can we detect them? Can we build that into the model where looking at the behavior inside of how the software is developed, that we can identify who is there with malicious intent?
Yep.
And so we see 3 use cases. One is the dashboard that we showed today for a controller, someone who wants to see across the entire landscape of projects and components. There's also the developer view, where we want to integrate it into the CI/CD pipeline, because as developers are doing their work, there needs to be, as soon as possible, feedback. Hey, this component, maybe take another look. And then, of course, we need to automate all of that and scale it. So that is what we have presented, prepared for you today. And we left some time to have some questions that you may have, to go deeper into any part of what we shared with you today. So we have a microphone in the back. If you raise your hand, the microphone will be brought to you so that we can capture your question also on the stream, on the recording. And if you don't have questions, then we have 8 minutes that we can talk about other interesting things that we find interesting. But there's a question, yes.
Yeah.
So yeah, I have 2 questions. So first of all, where did you get your information from regarding the risk? Do you just look on GitHub, or how do you pull those information from the dependencies regarding the community health and everything?
The metrics that we computed are all from the toolchain where the project is developed. In this case, it is GitHub, where the backlog management index is number of issues opened and closed. For the contributors, we look at who is actively in the Git log on the issues, comments, pull requests, reviews, who is active there. So all of these metrics we were able to compute from the source code repository and issue tracker.
Okay, so you're using those information, but basically you're concentrating your efforts on GitHub, so you didn't, or everything? Does it work with everything?
There's multiple sources. You can say, oh, the project is on GitLab, for example, so different locations for source code, but also different locations for storing issues, for example.
Okay.
GitHub has issues, but there's also different systems. So there's quite a broad list of sources where the information can be retrieved, but you have to provide the sources to the Bitergia platform.
Yeah.
Okay.
Yeah.
And your platform has that fully automated? Or do you have to manually do get some information?
The data collection is automated for 30 different data sources.
Okay.
With GitHub, GitLab, Jira, Confluence. We have other Bugzilla, whatever platform there is, we have many of them already supported. Right now, one of the things with the scaling up that we are talking about is how do we get it to start the collection automatically? Because right now we need to tell the system, hey, start looking at these repositories, these issue trackers, and so on. So that integration is something that we're working on right now.
Okay. And then the second question, how do you, so if you, for example, you had one example where you had 2 maintainers for the project. So if I have a very small project, like which is really just like 1,000 lines of code or something like that, then I mean, if I have 1 maintainer, that's enough. So do you include that into your risk analysis, or the number of lines of code, or some other metric where you say, okay, this is a really large project, or this is a really small project, and according to that, you adjust the risk level?
That is a possible extension. Right now, for what we did, it's not yet at that level. That is a conversation that because we're also doing metrics with the Eclipse Foundation, that we were thinking through just here at OCX, how do we group the different projects, how do we provide insights similar to this to the project at the Eclipse Foundation. So absolutely, that is something to think about. And do you have some thoughts on how you are approaching
it's a good question, because when we were doing the proof of concept, I was talking with engineers within our organization and say, yeah, but if we use a component that's perfect, right? There was no need for changes the last so many months, and it's not a black and white world. And it's also when you define these thresholds, I think you have to be really aware on these kind of aspects that you were just mentioning as well. So it's more than meets the eye, indeed. And I think that's also the way, when you start thinking about it, you learn from it, and you see that the world is not black and white, and you have to see how you deal with that. So that, those are aspects that we are also looking at. And maybe together we can improve all the nice features there.
Yeah. I can also give you an example where you don't want any activity on the project. In the medical space, when you have a research project that has been validated by experts, has been published, and then a medical company builds their devices for the market, because it's certified, if the software changes, they would have to go through the recertification process. So actually reversing this model, saying any change is a high risk for us, is another way that this can be adopted. Here's another question in the front.
Thank you for the presentation. Are there any plans to publish this information, integrate with Open Hub or something?
So we are talking about it. We are here to share the ideas.
Your risk analysis, like so like anybody can, like, I don't know, not ING, but anybody who is interested can go and see.
Yeah. The tooling, the underlying tooling to get the data, that's all open source already. And when it comes to making the risk judgments, that is something, at least in our experience, is very subjective. So I would be very hesitant to go out and say, I'm going to judge every open source project out there and make a specific
define the rule then,
defining
for
rule.
everybody.
Yeah.
You don't,
so this is more of changing the narrative of how we look at software, that we don't just look at licenses, vulnerabilities, but we're also looking at the community underneath it. That's the advocacy that we're trying to do, so that more can get involved in looking at how healthy is the community, the projects that is building all that software we are relying on. And this is one of the approaches.
Thanks.
Yeah, thank you very much. So on the previous slide, you talk about CI/CD integration there for the developers. Is this meant CI/CD of the open source projects, or the ones who want to use these health metrics to check their SBOM for potentially unhealthy dependencies? And if yes, is this just a database query via an ID like Perl where I get this then, or what? Could you elaborate more on this use case perhaps for the last few seconds?
Thank you for the question. What we're talking about is the latter. So we're not trying to impose anything on open source communities. This is about the users who want to build it, like in your tool chain.
Yeah. So give direct feedback. So while you're running your pipeline, that you get feedback immediately, because that's, or maybe even in your IDE, that could also be a possibility, of course. But these are things that we're looking into right now. So what are ways we could do that? And indeed, it's meant to be in the pipeline of where the SBOM is first created and then goes through the whole process of being analyzed, and then give the feedback, indeed, in the same process as your continuous integration process.
Okay, great. Then I would really welcome you to the Open Chain Tooling Workgroup so that we can discuss about this, because that sounds very interesting for me.
Okay.
Let's connect after the conversation here. Thank you. All right, we are technically out of time, but we're not cut off yet. So any last questions? All right. Thank you so much for staying with us.
Yeah.
Appreciate you.
Yeah. Thanks. Thanks very much.